Hello everyone and welcome to Felix's Space Time. In today's video I interviewed Jennifer Heldmann, a planetary scientist at NASA. It's amazing being able to talk to Jennifer about her work at NASA. If you like this video, make sure to like and subscribe. Enjoy.
Same type, we're go, flight.
Okay, we're go.
We're go, same type, we're go.
Thank you so much for coming on here for an interview. For those who are not familiar with you and your work, can you tell everyone a bit about yourself?
Sure. My name is Jennifer Heldmann. I work for NASA Ames Research Center, which is one of the 10 NASA centers that we have, doing all sorts of different interesting space and earth sciences. I am a planetary scientist by training, so my focus is on studying the moon and Mars. And mostly I'm interested scientifically in studying geology and also ices on the moon and Mars. And this is interesting, for science, like how did we get water in the inner solar system and where did it come from and what is it doing on the moon and Mars and where is it going? And also it's interesting for human exploration because as we send humans out into the solar system, we need resources that they can use, so we can have a sustainable presence on the moon and Mars. And so water ice is really important for that. So that's some of the work that I do at NASA. I do science and I get to go out in the field and go to exotic places that are like other planets, but are still here on Earth. And I get to work on space missions and technologies and operations. So it's a really fun job. It's a pretty good deal.
Amazing. It's lovely to meet you and to be able to talk to you today. How did you get interested in space and spaceflight?
Oh, that's a good question. You want the truth?
Yeah.
When I was about 10, there was this movie that came out. It's called Space Camp. Have you seen it? Oh, you should go look it up. It's a good one. So I saw this movie Space Camp and I thought, wow, that's really cool. And then when I got a little bit older, I actually went to Space Camp. You can go to Space Camp and learn how to fly space shuttles and do missions and wear spacesuits and work in mission control and all these things. So that was really, really great when I was a kid. And then I was just interested in space after that. And so studied it in school and I worked in the planetarium in high school and I volunteered at the Science Museum. And then I went to college and studied astronomy and physics and just did a lot of internships and tried to learn more about what you could do, working in space fields. And then I got a PhD and then I went to NASA and it's been great ever since.
Amazing. You kind of just answered part of the next question. For those who want to kind of get into your field of research, what kind of things do they have to study in school?
Oh, that's a great question. Well, I think right now it's very interdisciplinary. So you can study a lot of different things and still have a role, in the space industry. So for me, I studied a lot of science. I did, astronomy and physics and geology and math and chemistry and all of those things. So you're interested on the science side. A lot of people are interested also in engineering, all different aspects of engineering and building hardware and flying hardware into space. There's mission operations, so learning how to actually operate spacecraft. There's human factors, every space mission, people are sending these missions into space, even the robotic missions. There's a lot of people that are working. So how do the people interact with the software systems and the hardware systems and the operations to do that human robotic interaction? Even you can go into graphic artists to see all these beautiful renditions of the work that's done. There's finance, got to work the budgets and how you're going to pay for this and do all the things behind the scenes. Management, people that have to manage the missions, right? So there's all sorts of different ways, I think, these days that folks can get involved in space exploration. And it can be in the government sector, it can be in the commercial sector, it can be in industry, it can be in academia and at universities, at nonprofits. So there's a lot of ways, and science communication is very important as well. So I'm very thankful that you have this program where you're bringing all these exciting stories about space into the world. It's really great.
Amazing. Can you walk me through kind of a typical day, kind of your typical day at NASA?
That's a great question. I love that question because I have no typical day. And that's one of the reasons I love my job so much, because it's always different. So you never get bored because there are so many different things that you need to be doing. So Sometimes I'm looking at spacecraft data. I have to do that later today and look at the images that came from Mars and figure out what's going on the surface. Sometimes I'm writing computer code to try and figure out, okay, what's the ice doing and how is it going to behave? And is it going to stay or is it going to go? Is it going to evaporate? What's it going to do? Sometimes I'm going out into the field and doing field work and like walking on old volcanoes or going to, very cold places. The Arctic, the Antarctic are places that we go that are very cold to study ice. So sometimes you're out in the field, doing field work or geology. Sometimes I'm writing papers because you have to tell people about what you've learned. So that's an important part of it. Sometimes I'm giving talks at, either at public talks or science conferences, just depending on, what the venue is to tell people about what you've learned. I spend a lot of time in meetings. Some of them are fun. Most of them are fun when we're talking about like, oh, what missions could we do next? And, how could we learn about this? And, trying to brainstorm different ideas. And sometimes I'm just doing boring paperwork because I work for the government. So sometimes I have to do that too. So that's, I think, one of the greatest things is that there's not a typical day and it just depends on what's happening that day and what needs to get done.
Amazing. Lots of things to keep you nice and busy then.
Right.
What did you do before you started working at NASA? And what job were you doing when you first started NASA?
Oh, good question. I have to think back. So I did a lot of schooling. So I finished high school and then I got a master's degree and then I got a PhD. And then after you get your PhD as your doctorate degree, and after you do that, you usually do a postdoctoral research program. So I did that, and I did that at NASA. So I really kind of went straight to NASA. And even when I was in graduate school, I was working with NASA. I had a NASA fellowship. So I was always sort of in the NASA world, in the NASA sphere. And then after I did my postdoc, then I wrote some proposals and got some funding to keep doing science. And then eventually I got hired on and just stayed as a NASA employee out at NASA Ames Research Center. So I've kind of always been in the NASA world, but I think one of the good things was during college, I did a lot of internships at different places. I did one at the Space Telescope Science Institute studying Hubble data and looking at very distant galaxies and the star populations in there. I was a counselor at Space Camp one summer. That was great. I did an internship at Williams College in Massachusetts one summer and spent a lot of nights at the telescope taking data. So there's all sorts of different things you can do to kind of figure out what it is that you like. So I've just kind of bounced around and figured out, oh, I really like planetary science. That's a part of it that I really like. And I really like robotic exploration. And I really, really love the idea of sending humans to these other worlds.
Okay, wonderful. I believe when you served as the NASA Science Mission Director, was it, or Director or something?
I have worked in the Science Mission Directorate.
Yeah. So what kind of things were you involved in when you were there?
Yeah, so doing that, it was managing programs to fund scientists to do research. So there's a lot of really interesting science questions in planetary science and all different scientific disciplines that people would like to work on. So people write proposals, scientists write proposals, and then we look at those proposals, we have other scientists look at them, and then we figure out, okay, which are the ones that we should do right away, and then we fund those. So I was working on those programs to make sure that science could get done and to keep the ball moving and keep science moving forward. So that's a nice contribution to the community to, when you see those science results coming out, that's why.
Okay, amazing. I believe you have an involvement in the Artemis program, yeah?
Yeah, we are working on Artemis. Yes, that's true. So NASA has plans to send people to the moon, to the South Polar region, which is a part of the moon we've never been to before. Apollo, in the 60s and 70s went to the equator region of the moon. So we'll be going to the South Polar region this time. And it's very exciting. We've never been there. It's a really interesting place because at the poles of the moon, the sun comes in at a really low angle. So as it skims across the top of craters, for example, the bottom of those craters never see sunlight for like billions of years. So they're super, super, super cold, really cold. And if it's really cold, that's a really good place for ice. So I'm excited because we're going to be able to study some of that ice that's there. And there's also interesting geology that we haven't been able to study, all sorts of things. So we're working right now on what the science is that those astronauts will be doing on the surface. What are the questions that they should be addressing? And also, how are they going to do it? What are the tools that they need? They need like scoops to scoop up lunar dirt, right? And they need sample bags to bring those samples back. And they need instruments to take measurements. And so how is all of that going to work? So that's pretty exciting. And also training the astronauts. Because the astronauts have to learn about lunar science and how to do this. So there's all sorts of things that are going on right now to support Artemis.
Okay, amazing. So when humans do finally land back on the moon, what do you think the bases will look like at the beginning and when they're fully developed?
That is a great question. That is a great question. We don't know yet because they haven't been fully designed. So that work is going on, but the intent is to develop a base camp at the lunar South Pole. So what that will ultimately look like is in process right now. And so it's working on now, and then it'll continue to evolve as we move forward. What we do know, though, is that the first lander that will bring the astronauts down to the surface, that has already been decided, and that will be the Starship vehicle from SpaceX that will come down. It's this big giant thing that's going to land and bring lots of payload down and bring the astronauts down. So we know that that will be among the first landers to go. But then after that, we'll see. It's still being formulated and decided.
Oh, okay. So I watched a TED Talk where you talked a lot about Starship. So as you're involved in the future exploration of Mars, how will SpaceX and Starship help us explore as we've never done before?
Yeah, that's a great question. And thank you for watching my TED Talk. Right. So when we get to go to Mars, it's going to be so exciting because Mars is just intrinsically such an interesting planet. And the capability that Starship brings is like nothing we've ever seen before. And the reason is just because it's so big. It's so big. It can bring 100 metric tons of payload to the surface of Mars. That's a lot of payload. So that means you can do a lot of different things on Mars. So we can send people. We can do ISRU, in situ resource utilization. So we can, use that ice and sort of live off the land so we can stay there longer. We can start to build up a base. We can bring rovers so we can explore further away. We know from science, you want to traverse and you want to see different terrains and you want to go to different places to do your science. And then to do the science, we can bring so much science equipment. We can bring like laboratories and, big rovers and, put that in the habitat and have space to work and instruments and bring back lots of samples. So it's a really exciting thing to think about. And to be honest, we're really at the beginning of thinking about what we could do on Mars with a Starship because it's so different from anything we've ever been able to send before. So it's a really exciting time to be able to think about the possibilities.
Okay, amazing. So will the James Webb Space Telescope benefit your work, and how will it benefit your work with your studies of the moon and Mars?
Yeah, James Webb Space Telescope is amazing. That is an incredible feat of engineering and science. And I think it's so interesting because it's so large that it has such a large collecting area that you can look back so far in time and start to see things we haven't been able to see before. And the resolution is better than even Hubble. Hubble's amazing too, right? But you can see side-by-side images. You're like, wow, you can really start to discern. So one of the big questions that I'm scientifically interested in is, are we alone in the universe, right? Are we it? And how did we get here? So James Webb Space Telescope is going to help us answer those questions because it helps us get to fundamental things like how do stars even form? How do planetary systems form? How do we have other, solar systems around other stars and what do they look like? So this whole evolution on the cosmic scale is going to be phenomenal as James Webb Space Telescope starts collecting data and sending that back. And so it's really going to help fill in some of those gaps for our own understanding of our own place in the universe.
Okay. Okay, amazing. So what are your plans for the future at NASA?
My plans are to keep working on the lunar missions and the Mars missions, keep doing science. We're still analyzing data about the moon and Mars, trying to understand, the geologic history and also the history of volatiles and ices, and also working on Artemis, various aspects of Artemis, especially focused on the science and the science operations and the science tools and the science training for the astronaut crews. And then working on robotic missions. We have a mission going to the moon in a couple of years. It's called Viper, the Volatiles Investigating Polar Exploration Rover. And this is going to be a really cool mission because it's going to the South Pole of the moon. It's a rover. It's going to drive around and it's got a drill on it, and we're going to map out ice. And that's super cool because that's important for science and for exploration. So I'm going to continue working on Viper, and then we're also working on other mission concepts for both the moon and for Mars to study these science questions and to prepare for human exploration. So there's a lot going on, but that's good because it's all fun stuff.
Okay, amazing. That's all the questions I've got for you today. Thank you so much for coming on here for an interview. It was amazing to be able to talk to you, and it was amazing watching your TED talk. You had some very, very interesting things in there that I'd never heard of before.
Great. Well, thank you very much, and thank you for telling these stories about space. We really appreciate it.
Thank you very much, and I hope you have an amazing rest of your day.
You too. Thank you.
Thanks for watching. If you enjoyed, make sure to like and subscribe. Bye.